Here is my fourth DER of my grade 12 year, Project 3.4, Pin Change Interrupts, a project in which we were individually tasked with replicating a project developed by two ACES legends and alumni of 2021, Adam Goldman and Seb Atkinson, who were tasked with creating a clue capture or digital safe used in escape rooms to hold items for a project at the University of Waterloo. To replicate such a project, a basic circuit was necessary, housing a bicolored LED, a 4511 7-segment decoder, a 7-segment display, a 1 kilo-ohm fixed resistor, the ACES debouncer, and the icing on the cake, the rotary encoder, designed by Mr. Darcy. Within this project, one challenging component within the hardware course triangle being software, and within this project we were tasked with making it using only low-level code. To truly understand the software within this project, an understanding of the rotary encoder must be obtained, as it is pretty specific but a relevant component within not only this project but projects in general. Rotary encoders have 5 output pins, ground 5 volts being self-explanatory, and 3 output pins, SW, A, and B. Firstly, the SW pin is a switch, and when the rotary encoder is pressed, a low signal is outputted through the SW pin. The most complex portion of the rotary encoder is the A and B pins, both of which are staggered to the dial and subject to change, creating square waves shown on screen. Furthermore, such staggered changes allow the code to figure out the direction of the rotary encoder, either adding one to the digit on the 7-segment display or subtracting one depending on the rotation. To do so, we must compare the resting state of the output A to the value of pins A and B, determining direction. For example, if the encoder is rotated and a pulse is generated, values A state and A last state will differ. Next, using the second if statement, the rotation direction is found, because if the output from pin B is different from that of pin A, the counter moved clockwise and vice versa. An example of such shown through first a clockwise rotation, followed by one of counterclockwise direction. The second major component of this project within the code was the interrupts, used for the rotary encoder's button and the reset button. Interrupts, to simplify things, allow essential tasks to occur in the background and enable tasks within the code. Within such a project, an Arduino Nano was used as an MCU with 2 digital I/O pins usable for interrupts, pins 2 and 3, both populated within the pin change interrupt project waiting to be called upon. The reset interrupts, in this case, used to reset the code manually inputted by a user, and the SW interrupt is used to manually input a code. Ultimately, despite such a project rooting back to some of the fundamentals within the software world, out of my comfort zone, it was a pleasure, and a ton can be taken and will be taken from such a project to be implemented in my future.